Welcome to the video. Today we're going to talk about railway EMC and specifically about EN50121-4 EMC standard that applies to the equipment installed in close proximity to railway tracks or the equipment that has cables running in close proximity to railway tracks. To make this video a bit exciting, we will go to a test house and perform the tests specified by the standard one by one, and I'll explain along the way what you should be looking for while you perform this kind of tests. And this will be an example of qualification testing, after which the company can issue a declaration of conformity to the EN50121-4 standard. So if we look at the EN50121-4 standard itself, we will see that it is what I call an umbrella standard that refers to many other standards, specifically the EN61000 immunity standards, and as well as the CISPR 16 for application of emission levels. For example, on this page, there is a definition of conducted emission levels and the basic standard that applies. And then in the following page, it defines the performance criteria for the EN61000 basic standards. Then you will also see the table, which is very important, and that tells you what tests should be administered to equipment and what performance criteria is associated with those tests. So when we talk about performance criteria A, B, C or D, what we really talk about is whether or not the equipment has been disrupted during the test. And if it has been disrupted and there is some visible flickering or some change in state, then the performance criteria, it tends to be defined as B. However, if it has been disrupted as much as it couldn't continue normal operation and it had to be restarted, then the performance criteria would be C. Finally, if it broke down and no longer works, the performance criteria would be D. As you can see from this table, for most tests, the performance criteria is A, meaning that the equipment should not show any degradation signs, neither during or after the tests. Moving on, after the application of immunity in general, there is an application of immunity to input and output ports, and in this case I'm talking about cables that are incoming or leaving the product. So as you can see, those tests are the injected conducted noise, the fast transient, which simulates a noisy environment, and a surge, which can be a little longer than just a fast transient, but essentially simulates a similar thing, as well as potentially lightning strike somewhere in a building, not directly on the equipment, but if you have a bounce on the ground, then you would likely experience a surge in the mains or even on I/O ports. So this is what we're talking about when we define surge testing. There are several very important notes at the bottom of each table that should also be carefully understood. For example, where it says that the ports directly connected to power ports or to public low voltage network are classified as power ports also. So that means that any tests that are specified for AC or power input testing will apply to those ports as well. The next table is talking about immunity of DC power ports, such as PoE, for example. And the next table is talking about immunity on AC power ports, such as the standard 230 volt main supply. Effectively, as you can see, the tests are usually the same, and they involved injected disturbance and transients and surges. Finally, there are even 2 tests specified for the protective earth connection, but as you can see, we don't have to apply surges to that. This is effectively everything that the standard is talking about, and if you noticed, we haven't mentioned the emissions all that much, except for the first table that specified the conducted emissions. There was no mention of the radiated emission. Well, that is because of this sentence here in the beginning of the standard that tells you that the specific provisions are to be used in conjunction with the general provision in the EN 5121-1, and that standard will tell you that CIS per 16 emission levels should be applied, or in other words, that it should be Class A radiated emission levels. So having discussed the standard itself, let's continue with our testing in the test house. So when we want to do EMC testing, such as railway EMC, we have to go to a test house facility, and so that they can do this kind of testing for us. And the facility will typically have all the equipment we need, and they will also provide a person to oversee the testing and advise on following the correct procedures. But prior to that, I typically also write a test specification to make sure that I'm aware and in control of all the testing that's taking place. This also helps to get the right quotation in place. So welcome to the Large Anechoic Chamber in Intertek UK facilities, and this is a large enough chamber to even test a small vehicle or an industrial appliance, which you can roll in through those back doors into this turntable. The turntable rotates 360 degrees, and at the moment we have the 2 GHz antenna set here, that is set at about 3 meter distance. So this is necessary for us to test the radiated emissions up to 1 GHz, which is the first test that we're going to do. And then we will swap the antenna and do the radiated emissions test up to 6 GHz. The distance will change as well, because at higher frequencies the far field is going to be occurring at a smaller distance. The orientation of antenna matters, and as we will be testing first in a vertical orientation, it will then swap to horizontal orientation, and we're going to record quasi-peak measurement of both. So now the test is running, and you can see it's got quite a few spikes go over the limits. And you can see that effectively they're all multiples of 148 megahertz. And 148 megahertz, I'm sorry, is frequency of HDMI. You will probably see the spike here. Yeah, see, so this is 148 megahertz spike, and I know it's HDMI frequency, so we're dealing with dodgy cable potentially. I can also see that the limit's been set to class B, which isn't right because we're testing to class A. But yeah, I wonder if I can change that. I reckon that's what we're gonna do. I'm gonna put a little ferrite over the HDMI cable. So the radiated emission still gives lots of trouble. into atmospheric.
Is there any way to switch them off now? Well, I had to wait them for a bit time to cool down for it.
Oh, is it cooling down? Yeah. Alright. So looking like after a lot of mod it's maybe passing. Certainly a lot better than when we started, isn't it?
Yeah.
Yeah.
Yes, but not gone. Average.
There you go.
Faster radiated emissions now.
This makes a lot of noise. So that was effectively the radiated emissions finish, and with a lot of mods and ferrite added, a change of cables, we did achieve a pass. So now we're going to have to add all those parts to the bill of materials and make sure that we sell this unit exactly in the same way as all those mods applied. So this is a conducted emissions test setup. Reasons plugged in there. Can't put all this in. And this is the DAT, it's powering. So you can see IP address on this place, it's running. This is the footprint, which is similar to my pre-test results. So it's passing. It's very important to test radiated immunity inside anechoic chambers because the electric field you generate can be quite strong, and railway spec in fact requires you to test with up to 30 volts per meter. So it can easily create massive disturbance in the house or basically cause issues in the nearby environment. And especially important for people with fitted electric pacemakers, because if you accidentally tune into the frequency of the electric pacemaker inside someone's heart, you can literally kill someone. So this is why I suggest you don't do radiated immunity testing in DIY settings at home, and you always go to a test house to do this. So this is a very similar setup for low frequency radiated immunity from 80 MHz to 1 GHz. And we've got signal generator that's connected to the power amplifier. A bulky boy here, and you can see we're not loading it at all. So that generates about 30 volts per meter in the anechoic chamber, and is being measured through the dBm power meter and then converted to volts per meter by using a measured points in the chamber. This will be our test setup for 6 GHz radiated immunity testing. So on the other end, I already showed you what the setup looks like. And here the antenna is double log periodic antenna up to 10.5 GHz. So this is gonna be used to create 3 volt per meter or even up to 30 volts per meter electric field intensity on this table. So what's the parameters? Is it
Well, it's just measuring factor is measuring how the voltage of the current factor is going to defines extreme current.
yeah?
So normally you see nothing.
Okay. There you go. So this is the conducted immunity test setup. We are injecting radio frequency. We are injecting radio frequency noise into the mains cable. So this is done. Okay, so first things, it starts with a signal generator, which generates a tone, goes into the power amplifier at the bottom here, right, and then goes into a directional coupler box, which then splits in two. So first of all you get the signal feeding back into the power meter so that the level can be measured, and secondly the output of directional coupler goes through a bit of filtering and is applied into the mains, and then that's injected into the device under test. So it's quite a fiddly setup, but this is again 80% modulated 1 kHz tone, quite similar to what we've been doing for radiated immunity, and at the end of the day it's not that different. Test is running using compliance immunity TestX software, which is already pre-configured, and it sweeps what is it, up to 80 megahertz? What the test limits are?
It's from 150 kilohertz to 80 megahertz.
Yeah, from 150 kilohertz to 80 megahertz. Yeah. So it says it's gonna take 1 hour to complete. Okay. So the test has now finished. We've done the mains, the conducted immunity on mains input. Now we're gonna do also the Ethernet and HDMI port, so one of each, to do the input and output tests. So again, this can take quite a while if each test takes 1 hour, and the more IOs you have, the longer it's gonna take. The noise is injected through a capacitive clump this time rather than from mains. So this is how the connection was made. Still using pretty much exactly the same setup. It's also important to know that the capacitive clump is directional, and it's shown as an arrow here, so it has to follow this orientation. The DUT is simply isolated from mains now. Yeah, it does happen. But it's only on this display, so the other display is fine.
No, that's where injection HDMI.
Oh, it is injecting into that specific HDMI.
Well, it's only one HDMI per test.
Ah, okay.
We can try the other one to see what is this.
Yeah, we can try the other one. There's a 2 kilovolt test. It's the modified units. We went back to the all metal shield, so it should automatically change to negative pulsation after a while, so it applies it on line, neutral and protective earth. Okay. Still running. Test finished. Green light. Okay. I'm worth something. Oh, Jesus. That was the worst test I've ever done. So the fixes were to replace this connection, to replace this feed-through socket so that there is no grounding between HDMI shell and metalwork. Then second fix was to also add this thick HDMI cable. It wasn't possible to pass with just a small one that we used originally. And the third fix was to add a bonding wire, so for protective earth, straight from the IEC socket. So when we make this harness, we'll have to specify to have a little earth spur so that it can be bonded to the chassis. Yeah. That's how it is set. So we're finally getting the 2 kV plus on this monitor as well. When it's injected into HDMI cable. And what we had to do, we had to ground it to the floor, which will be representative of the country as well. So that's something I forgot to do last time I've been here. Well, just finished. So you're applying 5 pulses on positive, 5 on negative.
Nope.
How does it work?
We got 4 phase angle to do, 5 pulses on each phase angle, and each polarity have to do all 4 phase angle in 5 pulses. So each level we have to do 40 pulses.
Each level 40 pulses.
Well, we got 3 levels to do on live to line to earth and 2 level on line to line.
Yeah. Okay. So the setup is very similar to the Transient, but takes a lot longer. what are we looking for?
Performance criteria C only. So that's
At 0% it's C, yeah?
Yep.
So it just needs to come back on.
Well, it can be done manually also, so no need to worry about it.
It can even be done manually.
So let's see what we come back.
Okay, so we're just booting up. Yeah, it came back alright.
Yep.
So that makes it B, right? Yeah, this was set up for the magnetic field. It's a testing. So effectively, you just create a magnetic field through that coil, and you measure it with a fluke. So, and you measure it with a fluke. So basically, you know what the level is. Yeah, this is where the surge input is provided from that box. Yeah. So that's effectively the immunity testing underway. The only thing we really have to do now is the electrostatic discharge. That's the one big item on the list, but we'll do it later, as we always do ESD last, to make sure that we don't destroy any units, as the ESD test can be quite disruptive. It's quite rare that anything happens during these.
Well, the most thing happen would be on direct or
Yeah, usually.
definitely not this type of thing.
No, that's what I mean, yeah. Why is it in... Oh, okay. Have you done indirect horizontal as well?
Yep.
Yeah,
We should do that first.
I...
With the easiest one.
So that tells you to do it first, yeah. And now it's like direct. 6 kilovolt negative polarity. Yep. Nothing's happening. So this is a quick sweep with air discharge, yeah?
Yep.
And
Nothing happens.
we can see that nothing happens, yeah, because the box is basically
This one is not a boss, so it didn't count.
full metal. Oh yeah, of course it's gonna. So this one's done at 8 kilovolt rather than 6. So now the testing has been complete, and well, it's been quite a successful week of testing. Not so fast to do all those things, as you can probably see by now. It's a lot of immunity testing that takes the most time. We encountered some issues in the radiated emissions and had to introduce quite a few fixes, as you have seen. So this is quite often is the process. So as an EMC engineer or someone who attends the testing on a company side as a designer, you will be expected to be able to complete the test and introduce modifications on the fly. So for that you really need some specialist knowledge, and hopefully this is what I'm being able to give you on this channel. Please like and subscribe this video, and I'll see you in the next one really soon.